Hi all, I welcome you all to the next lecture today. So today we are going to start the discussion about space debris and its mitigation. It is basically a topic of discussion around the scientific community, right? How to eliminate the space debris, how to remove them. Lot of techniques are being invented, and some of them are already been tried, but still it is a challenge in front of scientific community to bring back the space debris, right, to the earth or leftover portion of space shuttle or whatever, unknowingly or knowingly, some components being left in the space and they are traveling at very very fast speed, which may be very very dangerous for the future space exploration and needs special attention. So today we'll see what are the space debris, how many types of space debris are there, and how to remove them, right? What are the possible methods, and whether it is necessary to remove the space debris or not. So let's start our discussion for today with the space debris. What is space debris? Space debris is nothing but it is also known as orbital debris, space junk, or space waste. It is the man-made objects that are in the orbit around the Earth that no longer serve any useful purpose to us, but still they are in the space and traveling at very fast speed. They can include anything from entire used rocket stages and defunctioned satellites to explosion fragments, pant flakes, dust, slag from solid rocket motors, coolant released by Rosat nuclear powered satellites, deliberately left pieces like either the toothbrush brush, right? It may be hand bag, it may be either gloves, right? Astronaut gloves that has left there in the space. So these are all the different things, right? So can be categorized as space debris. Currently, 200 new objects are added annually. So every year humans are basically contributing towards increasing number of space debris, and there is no solution yet how to reduce it and how to take back those leftover things to the earth. That's a challenging task. So space environment became unsafe by numerous debris produced during human space activities. So if you look at the first image, this is nothing but low Earth orbit. So this is very near to the Earth. If you look at these all dot things that you are seeing, these are nothing but space chunks which are traveling at faster speed. So if you are sending any rocket or any space shuttle to the outer atmosphere, in that case, if it is going to collide with the space debris, it will cause a larger damage to the space shuttle or rocket. And this is basically orbit called geosynchronous orbit, and is looking like completely circular because it is at very very high altitude, around 35,000 kilometers. Here also you see a lot of space chunks there. At current, what basically we are doing when our satellite is going to be defunctioned, what what is the possible solution that we are doing? We are just pushing it above the geosynchronous orbit, because for most of the purposes, right, communication, navigation and all, we are utilizing only space at geosynchronous orbit or low earth orbit. So once your satellite is going to be defunctioned or it is near the defunctioning, we are pushing it beyond the geosynchronous orbit, but it's not going to be a permanent solution. It is a temporary solution. What will happen in future when there will be large number of defunctioned satellites or unnecessary chunks which we are dumping in the space will increase, and it will be a big challenge in front of humans, right, to carry out the space exploration. When that is going to fail, we will be completely blank. What will be completely blank from navigation, communication and all will completely shut down. And that's why nowadays a lot of researchers are focusing on space debris removal techniques. So this is the picture basically taken from European Space Agency, right? This both the two pictures I've taken from the website of European Space Agency. Let's see some of the interesting facts, right, in the history of debris. In 1958, America's second satellite, Vanguard 1, went into orbit. It worked only for 6 years, but still it is up in the space. America has not thought of bringing it back because it is very difficult to track it. Because once it is defunctioned, we lose the communication to the satellite. If there is no communication, we cannot find out the exact location. So the most dangerous garment in the history orbited with a speed of 28,000 km per hour for 1 month in 1965. Edward White, a Gemini 4 astronaut, lost his glove during the first American spacewalk. In 1996, only 2 years after it went up, part of the Pegasus rocket made the most space debris by a spacecraft destruction. It created a cloud of more than 3 lakh pieces bigger than 4 mm and 700 of which were big enough to be catalogued. This event doubled the Hubble Space Telescope's collision risk. You might have heard about the Hubble telescope. USA has spent lot of money in that developing the Hubble telescope for navigation and communication. And for the safety of Hubble scope, USA is spending more than $200 million, right, for tracking the space debris and to avoid any kind of collision with the Hubble space. So these are the some instances which were happened in the history, and at that time, no one has taken any step to think for removal of space debris because till now even we don't know any effective method to do it. In 1999, it was estimated that there were 4 million pounds of space junk in the low Earth orbit, made up of 1 lakh 10,000 objects larger than 1 centimeter. Right? You might have, I will give you one idea. You might have watched the movie called Three Idiots, where, principal asked the question, first question to the, you know, Ranchodas that what will happen if a pencil nose left over in the space? He could not answer that, but at the end, principal Sas Buddhe, basically, he gave the answer. If that is traveling, that is left over in the space, that will be traveling at very, very fast speed. It may strike with the spacecraft, will create larger hole, or it may go to the astronaut nose, or even if directly made the impact over the astronaut, it may kill you there in the space. That much higher velocity it will attain. So impact will be more. So for example, a tiny speck of paint from a satellite dug a pit in a space shuttle window nearly about 1 by 4th inch wide. That has happened. The Mir space station sent more than 200 objects into space in its first 10 years of operation during the 1980s. Most of them were garbage bags. In June 2000, the total number of trackable space debris, including 90 space probes, 2,671 satellites, and more than 6,096 pieces of space junk. And over this, lot of studies has been done. There was a scientist, right, who did, study on this, and he found out that a future will come, a time will come when there will be very, very impossible to send a single satellite into the space. That is known as Kessler Syndrome. So when we talk about the Kessler Syndrome, in 1978, NASA scientist named Donald J. Kessler theorized that the volume of space debris in low Earth orbit is so high that objects in the orbit are frequently struck by the debris. Unfortunately, this multiplies the amount of debris and amplifies the possibility of further impacts. Ultimately, the vast amount of debris in orbit could make space exploration and even the use of satellites impossible in coming future. So, special attention need to be focused on it. Why is this bad? Take one example of collision of iridium 33 and Cosmos 2251. This one example, right? In an unprecedented space collision, a commercial communication satellite iridium 33 and defunction Russian satellite Cosmos 2251 impacted each other on February 9, 2009. Above North Serbia created a cloud of debris. Till now, over 1,719 large fragments have been observed. They have been observed only, they have not been captured. Also, you can see, as I said that every object which is left over in the space will be traveling in speed, very, very high speed, maybe 20,000 to 4,000 kilometer per hour. And this much speed is sufficient enough to make a larger impact. Larger impact. It means that even a small piece can cause a lot of damage to the space shuttle or the International Space Station. It can cripple satellites worth hundreds of millions of dollars. It can damage research satellites such as the Hubble Space Telescope, and it can even kill astronauts. These are some of the pictures, right? That real incident happened. Look at the tiny hole in the space shuttle Atlantis caused by the space debris NASA. This has been given by the NASA. So it is a very, very small piece which is stuck with the uh, space shuttle surface and made this much impact. Diameter is around 0.108 millimeter, and you look at total size. And if you look at the drill view, damage of the Hubble solar panel from space debris. So Hubble space having solar panels over that also this much diameter big hole was created due to the collision of space debris. So category of space debris, if you look at, there are basically three categories of space debris based on the size. Category 1, less than 1 centimeter, makes significant damage to vulnerable parts of satellites or shielding. Less than 1 centimeter parts are left in space is known as category 1. Category 2, between 1 and to 10 centimeter. This is very, very dangerous, right? When mass is keep on increasing, kinetic energy will also increase. So it will have a larger impact. So seriously damage or destroy a satellite in collision, no effective shielding. You can remove small pieces, but big pieces removal is very difficult. Category 3, greater than 10 centimeter. Destroy a satellite in collision can be tracked, you can easily track, right, from the ground. And easily you can see the maneuver for these kind of, debris, but less than 1 centimeter cannot be trackable. Even they can make a lot of damage, and but one good thing is that you can easily remove them. Lesser amount of energy you need to spend to bring back the category 1 debris, and slowly one by one you can remove the debris, but still we don't know the exact method by which we can do it. So space surveillance network, there is a space surveillance network. Basically, the purpose of space surveillance network is to detect and monitor the debris. So currently, more than 15,000 objects are tracked and kept in a catalog by space surveillance network. Space debris number is much more than the catalog. So you look at debris size. Based on debris size, quantities are also mentioned. Total number at all altitude is 0.1 to 1 centimeter is 150 millions, right? And 1 to 10 centimeter is 7 lakh 80 thousands, and greater than 10 centimeter around 23,000 debris. This is in geosynchronous. If you just focus on low earth orbit, out of this is the total number of debris. Out of that, most of the debris are found in low earth orbit. You look at low earth orbit, 20 million debris are of category 1, and category 2 around 4 lakh, and 15,000 debris are of category 3 low earth orbit. And low earth orbit is the first orbit you have to cross when you are going to the geosynchronous orbit. So if more number of debris will increase in low earth orbit, it will be very, very disastrous for the future space exploration, and we need to be take special attention. So this is basically taken from European Space Agency Master 2005 Debris Environment, and it was published in 2006 and 2008. Debris removal techniques. First is alternate orbit. You can change the orbit of the debris. If it is a big debris, you can push it from one orbit to the another orbit, so that let's suppose a low Earth orbit. If you are having big size, debris that can be pushed towards the geosynchronous orbit, so that low Earth orbit debris quantity can reduce. But this is not a permanent solution, because anyway, for better communication, you have to go to geosynchronous orbit, and you have to pass the spaces in between. If devices are present there, that will be catastrophic in future. So sometimes it will require too much fuel to deorbit a satellite from its path. In these cases, it can also be brought to an orbit where atmospheric drag would cause it to deorbit after some years. This has been done. The French Sport 1 satellite brought its time to atmospheric re-entry down from an estimation 200 years to about 15 years by lowering its perigee from 830 kilometers to about 550 kilometers. So just you pushed slightly down, right? Because of that, the rate at which it was coming towards the Earth, right, got decreased from 200 years to just 15 years. Other methods, there are other methods. Unfortunately, many other ideas are either too expensive or unrealistic. These involves particularly pulling space debris back into the Earth's atmosphere by using laser brooms to vaporize or nudge particles into rapidly decaying orbits, also called the Orient project. It's very, very costly, and still we have not got the success in that, but we're trying it. Use aerosol blobs to absorb impacting junk and eventually fall out of the orbit with them trapped inside. Instead, NASA currently focuses on preventing collision by keeping track of the large debris and preventing more debris from littering space. So this is temporary provision, right? NASA is doing temporary provision. They are just tracking the space debris. In what area space debris are more, they are avoiding that. At what time space debris are leaving that particular area, so that space missions can be accomplished, right? By that, they are finding out the windows. The window is nothing but the time, perfect time at which there is no unavoidable, disturbances present in that particular zone. But this is a temporary solution. We don't still know the permanent solution, and special attention needs to be put to find out the permanent solution of space debris. So space debris removal techniques, right? This called advanced space removal debris techniques are summarized here. So at low Earth orbit, which is approximately at 160 kilometer to 2000 kilometers, category 1 debris can be removed either with the help of a space-based magnetic field generator, sweeping or retarding surfaces. A space-based laser can be used. Right, for category 2 debris, right, between 1 centimeter to 10 centimeter size, you can use ground or air-based laser techniques. Category 3, more than 10 centimeter size, drag augmentation devices, magnetic shell, momentum tethers, electrodynamic tethers can be used, or you can capture orbital transport vehicle and bring back to the Earth. This is the solution for low Earth orbit debris. If you just focus on geosynchronous orbit, about 35,000 kilometer, then you have to go for some other solution called solar cell. You can send one solar cell there, which will absorb the debris on the surface, and finally you take that solar cell back. Or momentum tethers, capture orbital transfer vehicle using net or tentacles, etc. Here we will cover briefly some of those techniques, right, which have been proposed but not yet used. First is solar cell. The solar cell, this kind of solar panels will be kept in that low Earth orbit. They will attract the debris, will capture them. So an option for disposal of objects in very high orbit, requires no propellant storage or engine, but very difficult to deploy, and controllability is very, very difficult for this kind of solar cell. Second is drag augmentation device, right? It could be a balloon, this kind of balloon, that can be deployed on space debris such as usual satellites. If you send it, it will be traveling in this direction, right? This is a moving direction, so it will take the debris and will move towards the earth boundary, right? Not needed to maintain a specific orientation. No attitude control system is needed in the case of balloons. So balloon automatically will come towards the earth atmosphere. And last one is laser. And laser technique is shown to be the more effective method for space debris removal. So this is the original orbit, right? If you send the laser to the debris will change the orbit, so it will come to the lower side, right? And then you can track it, and you can destroy there itself, or you can capture it and redirect to the lower earth orbit. So once it come in contact with the earth atmosphere, it will destroy. So it is a feasible way to removal category 2 debris in low earth orbit between 1 to 10 centimeter. What it will do, it will burn the debris and bring the debris in the earth atmosphere. The moment your debris comes in contact with the earth atmosphere, they will burn off, and finally ashes will come down and get settled down on the earth surface. So laser basically, for high size debris category 3, we need a ground or air based laser, provide very high power. Technology is mature, right? Energy losses significantly by the atmospheric absorption could not be more freely in a huge range. Space based laser, right? In space base, if you put the laser, right, there will be no uh, disturbance due to the atmospheric absorption, right? So no negative atmospheric effects will be there. Be able to track and target debris with a much larger field of view. Focus on targets for longer period of time. The cost is slightly higher, right, compared to this. Can be space based weapon system. US particularly has already started working on it, on basically laser based technology, that is called Orion. Is aimed on the effectiveness of using ground based laser to clear up the space debris in low earth orbit. For most low earth orbit debris, the change of its velocity can be completed in a single transit of the debris. So in 2000, the US invested around 200 US million to research and ground-based laser experimentation to clean up debris, and intended to have experiment in 2003. So this was done in 2000 and 2003, but still US is hardly working on removing the space debris, and it requires efforts from worldwide space agency. They need to coordinate and work on removal of space debris, otherwise it will be very difficult, very difficult to do the future space exploration. So what do you think? Is space debris just another overhyped scientific issue, or could this really become a larger problem in the future, or should we leave it all up there or take the time and money to bring it down? So what is your opinion? I want to know your opinion. Please provide your opinion on these two questions. As per my suggestion, yes, space debris is very important, topic, and what we say, special attention need to be put to remove the space debris. Otherwise, it will be very difficult for the future generation, right, to use the benefit that we are using at present. Global positioning system, navigation, and all communication that we are enjoying the benefit today will not be available in future if space debris is going to increase in the low earth orbit. Very difficult to send the satellite then. Should we leave it all up there? No, this is not a solution. At present we are doing it, it's a temporary solution, but in future you have to remove them. So with this, basically I am closing the discussion. At the closing note, I have given you two questions, so I am expecting some of your opinion. You can give your opinion in the comment section. And if you are having any doubt in the current topic, feel free to write in the comment section, or you can directly approach to me on my WhatsApp number. I'll share with you. With this, your syllabus is over for the introduction to aerospace engineering. If you are having any doubt in any of the video lecture, feel free to contact me. Either you write in the comment section, or you can send me directly WhatsApp message. So thanks for your patience for today. See you all. Have a nice day. Good day.